The G80 locking differential will get you where you want to go, practically anywhere except at the side of a cliff, but we're working on it. We've successfully tested vehicles equipped with the G80 on inclines which are too steep for the average hiker to climb. You couldn't do this with an open or limited slip differential. Let's examine the differences between these three types of differentials used in vehicles today. Briefly review how they work and their unique benefits to drivers. Everyone knows where the engine is in a vehicle, but not everyone knows how the power gets to the road. In a rear-wheel drive vehicle, the engine turns the transmission. The transmission turns the drive shaft, which turns the differential, which turns the rear axle shafts, that turn the rear wheels and push the vehicle forward. It's called a differential because it allows the drive wheels to turn independently at different rates, such as when you're turning a corner. If the wheels turned at the same rate, the inside tire would hop and skip as you turn the corner. A simple solution to this problem is the open differential, which allows the drive wheels to turn independently. This works fine if you're on a smooth, dry road surface. But what about heavy rain, snow, ice, mud, and off-road conditions? In those situations, the differential will spin the wheel with the least traction, while the other wheel will not turn at all, because all the power is being transferred along the path of least resistance. You've experienced this if you've ever been stuck in mud or snow, or if your wheels have spun on water or ice. A limited slip differential, by comparison, has all of the same components as an open differential, but it adds a spring pack and a set of clutches inside. The clutch pack creates additional resistance whenever one wheel wants to start rotating faster than the other. This resistance created by the spring preload on the clutches has to be high enough to keep tires from spinning, but low enough to still allow the tires to rotate at different speeds in a turn to allow safe cornering. A limited slip differential works well on paved surfaces, but for serious off-road use and very slippery roads with snow or ice, a limited slip is not powerful enough to provide the traction necessary to keep the vehicle moving. A limited slip differential is a good product for performance vehicles, where a certain degree of traction is needed at all speeds, but not an effective solution for low-speed traction that's needed in pickups and sport utilities. But you won't get stuck if you have an Eaton G80 locking differential. Here's what makes this differential so special, and why your customers, once you've explained and demonstrated its advantages to them, will want one on their next vehicle. There are two flyweights inside the G80 that begin rotating when one drive wheel is turning faster than the other, signifying a low traction condition at one wheel, perhaps caused by rain, mud, snow, gravel, or an uneven road surface. When the difference in the two wheel speeds reaches 100 RPM, centrifugal force on the spinning flyweights overcomes the spring tension holding them in place. The spinning flyweight moves outward and engages the locking lockout mechanism. The second flyweight engages if you're driving in reverse. A second feature of the G80 locking differential is the vehicle speed lockout device, which prevents locking of the differential at speeds over 20 miles per hour. When a vehicle operating with a locked differential starts moving faster than 20 miles per hour, the rotational speed of the larger lockout device overcomes the spring tension holding it in place and prevents the differential from locking. The rear axle then operates as an open differential. Now let's look at an Eaton G80 locking differential from the inside. Remember that the blue gear is being turned by the drive shaft. Ordinarily, the power, or torque, goes to the wheel that is easier to turn. When one drive wheel starts rotating 100 or more RPMs faster than the other drive wheel, one of the spinning flyweights engages the locking lockout mechanism, which in turn stops the larger lockout gear from turning. This is the gear used to prevent lockup at speeds over 20 miles per hour. After the gear stops moving, the locking mechanism forces it up a ramp away from the blue gear, causing it to engage both the left and right drive shafts inside the differential. Now both axles are locked together and turn the drive wheels at the same speed. That means if either tire is touching the ground, the vehicle will soon be on its way.